A physicist believes that the entire universe could be a neural network. It's not every day that a study attempts to rewrite the fundamental rules of reality. However, Vitaly Vanchurin, a physics professor at the University of Minnesota Duluth, has proposed an eye-opening idea in a preprint published on Archive. He suggests that we might be living inside a massive neural network that governs everything around us. In other words, he argues that the entire cosmos on its most fundamental level is a neural network. Physicists have long struggled to reconcile quantum physics, which treats time as universal and absolute, with general relativity, which sees time as relative and intertwined with the fabric of space-time. Vanchurin claims that artificial neural networks can display approximate behaviors of both theories. He writes, "It is widely believed that on the most fundamental level, the entire universe is governed by the rules of quantum mechanics. And even gravity should somehow emerge from it, since quantum mechanics is a remarkably successful paradigm for modeling physical phenomena on a wide range of scales." The paper asserts, "We are not merely claiming that artificial neural networks can be beneficial for evaluating physical systems or uncovering physical laws. We are saying that this is how the world around us actually works." He views this as a potential theory of everything, which should be straightforward to disprove if incorrect. Most physicists and machine learning experts contacted declined to comment on the record, expressing skepticism about the paper's conclusions. However, in a Q&A with Futurism, Vanchurin elaborated on his concept. There are two ways to approach this idea. First, one can start with a detailed model of neural networks and examine how the network behaves when there are many neurons. Vanchurin has demonstrated that the equations of quantum mechanics accurately describe a system near equilibrium, while classical mechanics accurately describes a system further from equilibrium. This might seem coincidental, but these mechanics describe the physical world as we understand it. Alternatively, one can start with physics. We know that quantum mechanics works well at small scales and general relativity at large scales. But we haven't unified them, a problem known as quantum gravity. Moreover, we struggle to account for observers, known as the measurement problem in quantum mechanics and the measure problem in cosmology. One might argue that quantum mechanics, general relativity, and observers need to be unified. While 99% of physicists believe that everything should arise from quantum mechanics, no one knows how. In his paper, Vanchurin suggests that a microscopic neural network is the underlying structure, from which everything else, including quantum mechanics, general relativity, and macroscopic observers, emerges. So far, this hypothesis holds. Initially, Vanchurin wanted to learn more about deep learning, so he wrote a paper titled "Towards a Theory of Machine Learning." The plan was to use statistical mechanics to analyze neural networks. But he found that the learning dynamics of neural networks resemble quantum dynamics in physics under certain conditions. During his sabbatical, he decided to explore the theory that the physical world is a neural network. It's a crazy idea, but perhaps it's crazy enough to be true. We'll have to wait and see. There are many theories of everything, and most are likely wrong. According to Vanchurin's hypothesis, everything is a neural network, so to disprove it, one would need to find a phenomenon that neural networks cannot explain. This is challenging because we still don't fully understand how neural networks function or how machine learning works. That's why he initially set out to develop a theory of machine learning. The idea is bold, but is it bold enough to be true? Only time will tell. Subscribe for more videos like this.